Okay, so thank you for joining us, everyone. We are very excited to have, Chris Belter joining us today. He is the lead analyst and evaluator for the Division of Extramural Research at the UNICE Kennedy Shriver National Institute of Child Health and Human Development. He has a very interesting topic to share with us today, so I will just let him get to it. And again, this webinar is being recorded and it will be posted on our RTD TIG YouTube channel after today. So take it away, Chris.
All right, let me get myself set up here. All right, great. So again, thanks, Dee Dee, for the invitation to talk to you all today, and thanks everybody for coming. I think it kind of goes without saying that generative AI and the sudden emergence of generative AI has really caught a lot of people off guard. It sort of emerged very suddenly and has a lot of us sort of thinking about what this technology can actually do for us, what can it not do, how might we be able to use it, what's going on, like all of those kinds of things. And we're having to deal with this relatively quickly as not only the technology emerges, but also as the technology changes and adapts and moves at a very quick rate. So in that light, this is something that I've also been thinking about a lot recently. So I wanted to share with you a little bit about a project that I've been working on in collaboration with some folks over at Elsevier. Really for about maybe the past year or so, we've kind of been plugging away at this sort of in our spare time, so to speak. So we've been working with this to just sort of see what can we do with it, how can it work, and that kind of thing. So I want to begin, though, by talking a little bit about some of the background for generative AI and what people are sort of thinking about and thinking about in terms of how AI could be used in sort of the general scholarly communication ecosystem, by way of giving some background for what I'm doing, why I'm doing it, and how I'm sort of approaching things. A lot of this is adapted from a really fantastic review article that was published in Nature a couple months ago. I've got the DOI cited down here in the slide. So I really highly recommend you checking that out. So some of this content is adapted from that. It's expanded based on my own thinking, etc. So these roles that were identified both in the article and then from how I think about things are in many ways attempts to address problems that we see in the scholarly communications ecosystem. And so the idea is that AI is going to come in and sort of save us from these sort of big problems that are certainly out there in the scholarly communication ecosystem. So the first role that people are proposing for AI is this idea of AI as oracle, or the idea that this AI is going to be this sort of all-knowing resource for us to sort of ask questions of. And the idea here is that it's going to solve us from this problem of it being very, very difficult to keep up with the scholarly literature as it evolves. So as the pace of scholarly publishing increases, as the sheer number of articles increases, and as these articles become increasingly
Can you bring me my coffee,
technical and
buddy?
sophisticated.
Bring me my coffee.
If folks please could mute their phones, that would be great. So as this scholarly communication grows in both scale and complexity, it's becoming more and more difficult for us to keep up with the literature. And so the idea here is that the artificial intelligence or the algorithms will essentially read everything that's ever been published and will continue to read everything that ever is published, and will be able to understand that literature to such a degree that we can just ask questions of the machine rather than having to actually read the articles ourselves. So we would essentially be able to ask questions about what did this particular paper find, or what's important about this paper, or tell me about the state of the science in this particular field, or tell me how things are changing in a field, or whatever we happen to have questions about. The AI will be able to actually tell us all of that information. So we'll essentially outsource the whole like reading journal articles task to the machine, and we'll just be able to ask it things. The second potential role for AI in scholarly communications is around this idea of AI as arbiter. And this one is in particular around a couple of problems that we see in scholarly communications related to peer review and reproducibility. So the idea is, again, that the AI would be able to actually tell us and essentially do the peer review process for us. So as we all know, peer review is becoming increasingly difficult to do. It's becoming increasingly difficult to find reviewers who have adequate expertise and the time to actually review things. We also don't necessarily go as far as maybe many would like in terms of reproducibility, checking whether data is correct, where approaches are correct, all of these other things. And so the idea is the AI would actually be able to do all of this in the review process. So we would basically just give it a manuscript and it would do all of these checks. It would check for whether this is an appropriate method. It would check the methodology. It would check the statistical approaches, whether the data has been shared, all of these things, and then come to a decision about whether or not this article should actually be published. So I want to pause here and just sort of put out the observation that what we're essentially talking about here between the roles of AI as oracle and AI as arbiter is we're really talking about essentially outsourcing the vast majority of the work involved in the scholarly communication ecosystem to machines, right? So we're essentially saying the machines are going to write the papers. They're then going to review the papers to say whether or not they should get published. And then they're going to read the papers and tell us what happened. So essentially, the vast majority of the work in the scholarly communication ecosystem would just be outsourced to the AI machines and algorithms. The final role that I see in scholarly communications that is particularly relevant for us as evaluators and particularly relevant for bibliometric and scientometric types of research is the idea as AI as an evaluator. So based on this role of the AI being sort of this all-knowing source of truth about what's happened in science, and with its ability to potentially be able to judge the quality of papers, we would essentially be able to ask it questions that typically we use proxy measures for. So we could essentially ask it to tell us what's the impact of a particular paper, or how is this particular field of science been influenced by other things, or how has science adapted based on the introduction of a particular topic, or how have people changed the ecosystem? What's the impact of science or countries or institutions or whatever? So essentially, again, because the AI has read and understood everything, it would then be able to tell us these kinds of evaluation impact stories because it has that knowledge. It's actually read everything. So this is potentially a paradigm shift in fields like bibliometrics and scientometrics, where we often rely on proxy measures because we can't rely, or because we just can't read everything, right? So either when we're talking about impact or talking about evaluation in scholarly communications, we're either having people read very small numbers of papers and relying on their qualitative judgment, or we're relying on indicators which become increasingly sophisticated and fancy and whatever to tell us what might have happened. with the emergence of AI, we're potentially talking about completely changing that entire approach and going directly to the source, as it were, and saying the AI will actually be able to tell us rather than us having to rely on these proxy measures. So that's a big change. And that's a big shift in what we might potentially be doing as a field moving forward. So with that as background, I then wanted to come at this project with a couple of sort of overarching framing questions. The first of which being, are we there yet? Are we anywhere close to being able to use AI to do any of these things? Is the technology at all ready? And then along the way, what could possibly go wrong with this kind of an approach? What could possibly be the danger with outsourcing all of these kinds of tasks to machines? So that's kind of how I'm approaching this. So that brings me to the actual project that we worked on. So let me tell you a little bit about how that all came about. So at NICHD, I'm the lead evaluator and analyst for the Division of Extramural Research at NICHD. So my job is about helping NICHD use data to inform the decisions that we make as a funding agency. So I get up to a lot of different things. I use a lot of different tools and approaches and do a lot of things. But one of the things that I often find myself needing is a way to sort of figure out where to look. So when it comes to things like evaluation, impact, and other things, I maybe think about things a little bit differently than maybe you might expect or maybe other people might expect. I'm not so interested in the overall impact of everything that we do. And the reason for that is that I don't think everything should have an enormous, like, paradigm shifting impact on science, because that's just not the way that science works. Science works through a series of incremental advances. And if we're looking at the overall impact of the entire portfolio, it's sort of implying that everything should be paradigm shifting. Everything should be amazing and incredible. And I just don't think that's a realistic way to approach it from a funder perspective, or at least from a project funding perspective. What I'm much more interested in is finding impact stories or finding breakthroughs that have actually occurred from the funding that we've given out. So what I'm more interested in is not what is the overall impact of everything, but rather where have we really had significant breakthroughs or significant advances that either change how we think about things or that really change how we treat people in practice. So what I'm often looking for is a way to go from maybe the 4,000 active research projects that we currently have funded at NICHD to what are the ones that have actually had meaningful impacts on either research, patient health, or broader population health. So essentially what I'm looking for is a needle in a haystack, right? Out of this set of 4,000 active projects, or about after the tens of thousands of projects that we've funded over the last 10, 15, 20 years, which ones are the ones that had real impact? And then what was it about those projects that really made a difference? So again, I liken this to trying to find a needle in a haystack, because out of this set of tens of thousands of papers or tens of thousands of projects, where should I look to try and tell those impact stories? How do I find those? So if you've ever seen Avengers Age of Ultron, you'll know that looking for a needle in a haystack is actually relatively simple if you bring a magnet. So what I'm looking for is the equivalent of a magnet that would filter through all of this information and bring me to the project that's actually of interest to me. Another way to think about it is I'm looking for the equivalent of a treasure map, right? It tells me to look here, dig here for buried treasure, as it were. Because if I know where to look, I can then do the qualitative work necessary to really sort of connect the dots. But I can't do that for everything that we fund, so I need to know where to look to be able to focus my efforts on those particular case studies, on those particular impact stories, that then we can then use to go back to Congress, tell the public, hey, we found this treatment that cured this disease, or we found this diagnostic that allows us to identify disease much more quickly so that we can provide treatments upstream so that we improve people's health, or other things of that nature, because that's really what we're interested in telling. And so I need a way to find those things. So that then brings me to the collaboration with Elsevier. So Elsevier has kind of also been thinking about a lot of this stuff. And I'm working with a particular sort of pocket of Elsevier where they're sort of thinking about how can they build a product around this idea of research impact. So what they're doing is they've sort of come up with a framework for sort of the components that we talk about when we talk about impact. So their components are things like collaboration, durability, significance, engagement, reach, etc. So these are sort of the components of impact that people frequently talk about. Not thrilled with this framework, but it's a framework, whatever. So what they've done is they've built a series of measures around each of these aspects and then said, all right, rate publications within a project based on these various criteria. So there's this whole sort of suite of measures around each one of these components that they're using to say, how influential is this set of papers in this particular aspect of impact, and then sort of creating this sort of footprint diagram out of that to kind of give a snapshot view of what the sort of range of measures would look like. They're also then bringing in generative AI to summarize what these projects and what these publications look like in each one of these aspects. So essentially they're saying to the AI, summarize this project in terms of significance, summarize this project in terms of its durability or its collaboration, and et cetera. To write these sort of impact case studies around each one of these different aspects that we might then be able to use to pick up on to say, okay, this is why it was rated the way that it was. So they're essentially trying to use the AI to summarize why a particular project got a particular score. So that's kind of what they're working on. So that then leads me to the project, because we thought, maybe we could use this particular tool as the equivalent of a magnet or a treasure map for me to be able to find these particular studies, right? And so the idea was, let's test whether or not this thing actually works based on some projects that we feed it. So what I did is I went through and picked a set of 10 projects that we knew were influential, right? So we've got these impact case studies on our website. We've got all of this institutional knowledge of stuff that we just sort of happen to know about in our project funding, and said this thing happened because of stuff that we funded, right? So we just sort of have this institutional base of knowledge. And that's great, but my hunch is that for every one of those things that we know about, there's probably 2 or 3 that we don't know about. And so again, what we're trying to do is find those additional impact stories so we can develop them into case studies. So we selected 10 of these, right? So of these 10, I know what these are, I know these were influential, and I know why they were influential. And so what I did is then I took another 10 completely at random from a set of projects from the same general range of fiscal years and project types. So again, I didn't have a set of ones that I knew weren't influential, so I could do that. But the idea was, at least if I picked 10 at random, chances are these are probably not particularly impactful projects. So we actually have sort of a test case where we know which ones are influential and which ones are probably not influential, and then see, could it actually tell us the difference, right? So I provided all these projects, the set of 20 projects, provided them to Elsevier. Elsevier didn't know which was which. I kept them blinded to that and said, all right, run this set through the generative AI, run it through all of your tool and see what happens. So structurally, what we did is we provided the grant text. This all came from a reporter. And so we ran the grant text, the project titles, the abstracts, and public health relevance texts. And then we provided all of the publication abstracts and then fed that into, I believe at the time it was ChatGPT 3.5 to generate these case impact studies, and said, all right, could these tools actually tell them apart? Could it tell us could it correctly tell us which ones were influential and which ones weren't? And then most importantly, could it tell us why? Could it tell us why these things were different? And could it tell us the correct impact story? Again, because we know what the correct impact story is, we can actually test it and see, did it get the story right? So we did that, I think, early last summer and got the results back last year. So let me talk through a little bit about what actually happened as a result of this. So we got the results back. We sort of had this big unblinding session. And it turns out that they actually got about 80% of the projects right. So they got eight of the 10 were correctly identified. There were 2 that I had that the project didn't rate very highly. And the project, or the AI tool, rated another 2 very highly that weren't on my list. So as a first pass with some relatively crude indicators, this actually seemed pretty good. This actually seemed pretty promising, right? But when I started to dig into the actual impact statements, it became very clear very quickly that they were just not great, unfortunately. And what I mean by that is that there were certain sets of problems that emerged from these impact statements. And then I'll sort of walk through sort of thematic areas of why it sort of fell down and sort of what happened along the way. So the first problem that we ran into was what I characterize as being the hype problem. If you are NPR fans, or if you are generally from the Midwest, you might also know this as the Lake Wobegon problem, where all of the children in the town were above average. Unfortunately, all of the papers, all of the projects were just fantastic. Reading these case studies, all of them were doing this really cutting edge research that was at the bleeding edge of their field. They were going to change the way science was done. They were going to have significant impacts on patients. Every single one of them was just amazing. And so from a validity standpoint, this seems fishy to me, right? Because again, from our understanding about the way that science works, particularly from Thomas Kuhn and others, we sort of have this understanding that most science is what he characterized as being normal science, right? It's incremental increases that in aggregate move the field forward. So this just didn't seem plausible that every single one of these things was cutting edge and amazing. And then also, there's a practical problem with this, because if everything is great, I don't actually have any additional information that I can use to tell me where to look. Because if everything is great, then nothing is great, right? So this was sort of a problem with the sort of out-of-the-box ChatGPT interface. Now, I will say that in retrospect, this is actually a parameter within the generative AI tools that you can actually dial up or down. So in future runs, we're testing the effect that parameter has on this particular problem. I'm told that dialing this back a lot really cuts down on this problem. But again, that's sort of a future us thing. And so if you just ran it through ChatGPT without any parameters, this is something that's going to come up. Another problem that came up was with a particular project. There was an attribution problem where the algorithm didn't know what a review article was. So one of the projects that it identified and said, hey, this is really influential, that wasn't on my list, turned out to be a project where there were only 2 publications associated with that project, and said, hey, this project is really great. And reading the impact statement, it was like, oh, it had found this, 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 and this, and the authors had done all this amazing work, and it was going to change the field, blah, blah, blah. So it turns out what actually happened was the AI latched onto one of those papers, which happened to be a significant and substantial review article on the state of the science in this particular project area. So essentially what the AI did was it read this paper and it attributed all of the research that was summarized in this paper, that was in fact done by probably hundreds of other people, to the project itself, rather than understanding this is a review of stuff that other people did. It attributed all of the science summarized in this paper to the project itself. So that's an issue, right? If we were just going in, reading the impact statements, we wouldn't necessarily know that this was actually what happened. So this is another one of those cases where if you just sort of use things out of the box, you're gonna run into problems like this. And that's a significant problem when we're trying to tell a story about impact. Another problem we ran into was something I called the scaling problem, which meant that essentially the more publications there were associated with a particular project, the worse the AI did in terms of actually summarizing things. We found that in practice that if there were maybe 10 to 15 papers, it did a reasonably good job in telling us what actually happened. But if we scale much beyond that, we started just getting almost to the point where we almost got gibberish back. It had real difficulty in summarizing lots of papers. In a lot of cases, because of just sort of limits to how much text you can actually put in a given prompt. Now, again, this might be a technological solution. Other models or future models might be able to handle more text, but in the current set, we just started getting really wonky results when we scaled to higher numbers of publications. So for some of these projects where the project had been running for like 20 years and had like over 1,000 papers, this really becomes a limiting factor in our ability to actually use it to evaluate that particular project. Related to that is one of the problems that I think is the most fundamental about using generative AI for this purpose, which is to say that the AI didn't know what to focus on. So if the project had multiple outputs or it found multiple things, the AI didn't know which thing to focus on. It didn't know which thing was important about a particular project. So there were projects where, or there was at least one project in the set of 10 that I'd given it, where the point of the project was one thing, but what the significant part or the significant findings was sort of one of those things that the investigators happened to find along the way. So it was not necessarily as related to the point of the project, but the finding was significant in moving the field forward. The problem is the generative AI focused on the point of the project and didn't know that this other finding was the thing that was actually important about this project. In other cases, what the AI would do is it would seem to sort of focus in on something sort of at random, or it would sort of approach the task as if it were a summarization project, a summarization task, and it would focus in on the things that were the most frequent. So if you had finding one and that finding one had the most papers, it would focus in on finding one rather than findings 2, 3, and 4, even if 2, 3, and 4 might have been the thing that was actually significant. So out of the box, it doesn't understand which thing to focus on, which is a fundamental flaw, in my opinion, in the generative AI's ability to actually complete this particular task. And then finally, again, sort of a fundamental problem that we ran into was this sort of echo chamber problem, where in retrospect, we realized what it was actually doing was it was telling us the importance of a project based on the project itself, rather than the impact of the project on everything else. So it was really this sort of insular sort of reference chamber where the AI was sort of relying on the actual project investigators and the actual project associated text to tell us what might be significant about this project rather than looking outside. And again, this is sort of a fundamental flaw in the conceptual understanding of what we're trying to get this thing to do, is because impact is by its nature on stuff that is not this project, right? What we're interested in is tell us the impact of a project based on everything else, on everything not this project. And that's not what the AI did. It's sort of stayed within this sort of insular set of things within the project, and it didn't go outside that. And so one of the things that we need to sort of go back to the AI to do is to say, to look beyond just this. We need to tell it to leverage all of the information from its training data to be able to actually summarize what was important. And right now, we haven't figured out a way to actually get it to do that. So those were the projects or the problems that we ran into within our sort of pilot project. But I also wanted to spend a little bit of time talking about other potential problems that we might run into when using generative AI for this purpose. So to be clear, these are not problems that we actually experienced in our project, but conceptually they are problems that we might run into when we're tempted to use generative AI for these kinds of purposes. And there are things that I think we need to be aware of. So the first is this trust problem. And this is something that I've noticed throughout my work with bibliometrics and scientometrics, is that we sort of have this inherent tendency to want to trust the latest and greatest approaches. We have this sort of tendency to say, if this thing uses all of the latest technologies and it's using all of these different inputs and has all of these corrections and is doing all of this very sophisticated math under the hood, that of course it will give us better answers. We sort of have this inherent tendency to want to believe that things are correct, or that very sophisticated analysis approaches are just going to tell us the right answer simply by nature of the fact that they do a lot of things. And that's, in my experience, that's just not the case. It's not necessarily the case. This is particularly acute when in the context of using generative AI, because generative AI is designed to produce believable text, right? It's designed to produce text that sounds authoritative and it sounds right. And there's been research actually done that where people actually rate the credibility of AI generated text above that of text generated by subject matter experts, actual humans. So when we combine the sort of inherent tendency to want to believe the latest and greatest with an algorithm that is designed to be believable and designed to produce text that sounds right, we may have an inherent tendency to just believe whatever the algorithm tells us without necessarily questioning or digging in. And if we do that, we'll start to run into some of the problems that I mentioned earlier. So that's something that we as users of this technology really need to guard against. Another problem that I think we need to guard against is the effort problem. And this comes out of the context in which evaluations and analyses often take place. So as analysts and evaluators, we often have a lot of things on our plate, and we have a lot of things that we need to do and a lot of things that we need to turn around. And typically we don't have a lot of time to actually do them. And so this sort of a situation encourages us to unfortunately take shortcuts or not spend the amount of effort maybe that we should in doing evaluations. And so again, this is something that we really need to guard against, and is something that we need to be particularly aware of in the generative AI context for, I think, two reasons. One is that we might not spend enough time up front generating prompts that actually tell us what we want to know. There's this whole emerging field of like prompt engineering popping up around generative AI, because there's an understanding building that how we ask the question influences the result that we get back. And just simply phrasing the question differently could completely change the nature of the response that we get back from the machine. And so if we're in a time crunch and if we're trying to juggle a lot of projects, we might not take time to actually generate prompts that are meaningful and will produce the answers that we're actually looking for. And then on the other end, we may be tempted to not really dig into the results or the impact stories that we get back. And again, this is a particularly problematic because if I didn't happen to know about what actually happened to these projects, or if I didn't really dig into the impact stories that emerged from these things, I would have never known about many of the problems that I just talked about. So in contexts where we're trying to do a lot of things very quickly, we have to guard against the tendency of just simply accepting the results at face value and really taking the results with a grain of salt and digging in and saying, is this actually even an accurate answer? Because right now, we're not sure. And based on what I've been able to see, we can't necessarily say that these are actually even relevant answers to the questions that we put in. So again, something we really need to guard against moving forward. And then finally, of course, the elephant in the room here is the bias problem. We know very, very clearly from a very long line of machine learning research that machine learning approaches and tools trained on biased data sets will be reproduced in the models that we train them on. The models will then reproduce those biases and use those biases in making decisions on future data sets. So when we think about bias in terms of generative AI, we often think of terms of bias that's sort of explicit in the text that we actually give it. And so we might sort of be tempted to think that if we just train it on, or train a model on scholarly literature, maybe we won't have so many of these explicit biases, and maybe that won't make their way into the model. But unfortunately, I don't think that's actually true, because let's be real here, the scholarly literature was written by and large by older white cisgender men. And so if you're training text that was produced by a biased set of authors, there are potentially biases that will make their way into the model, whether or not the text is explicitly biased. There might be linguistic tendencies embedded in that language. There might be things around sentence construction or word choice or ways of framing questions that emerge from this biased set of literature that may be very, very difficult for us to actually see in models trained on this particular set of literature. So again, I think this brings up two very fundamental questions. One is that will it inherit bias from the scholarly literature or other literature that it's trained on? And I think the answer is probably yes, because most of the literature that it's being trained on is inherently produced by a biased set of authors. So it's going to inherit some of those things. And then more fundamentally, will we even notice those biases in the results? Again, we may be talking about very, very subtle things here where we might not necessarily notice in a given project or even a set of projects. We really will only be able to notice it at a population scale or a very large scale, and only if we actually actively look. And so when we're dealing with things in context of the effort problem and the believability or the sort of trust problem that I mentioned earlier, this becomes a really inherent and sort of insidious kind of thing that we really need to look out for moving forward. Okay, so where does all of this leave us? And where are we? Where do we go from here? So I think where we are is actually very similar to where we were in the early 2000s. So bear with me here as I explain. So in the early 2000s, there was this internet meme that was going around on message boards and social media and everywhere around this phrase, all your base are belong to us. So this phrase actually came from a Japanese video game manufacturer. So this Japanese video game company had this game called Zero Wing that they were about to release. And they said, oh, we'll do some English subtitles. So because the text was all in Japanese at that point. And they said, oh, we'll just sort of throw some English subtitles at it to make it more sort of marketable to US and other consumers. So they just got somebody randomly in their PR department to just kind of throw some English translations at this thing and just roll with it. And so what happened, of course, is it became sort of a byword, not only for like us being able to do everything and have like, you know, just produce things, but also for as like a byword for people taking shortcuts. Because if anybody had actually gone and looked at this and got an English language translator, this would never have happened. If they had actually gotten somebody to read it, somebody would obviously have noticed, but they didn't. They didn't do any of that stuff. They just sort of took it as it was and just sort of ran with it and looked foolish as a result. What I think we can take from this is I think we're actually in a very similar situation with generative AI, where we're seeing these results and they look great, right? They look great because we don't know any better. They look great and we're starting to use them without necessarily understanding the full ramifications of what we're doing and what potential errors we might be making along the way. And so I think we need to take a lesson from this and sort of hit pause a little bit and say, let's actually do a bit more validity testing and make sure this thing is actually telling us what we think it's telling us before we actually start using it. Because what I think we need to guard against is text that sort of looks like this, or have the equivalent of this all your base are belong to us kind of moment. So this is actual generated text from ChatGPT. And anybody who's ever used ChatGPT on a regular basis will know that sometimes it just goes cuckoo. It just starts generating text that's just gibberish. And so what I think we need to guard against is not only just like the things that seem or that are obviously just crazy like this, but I think we also need to guard against things that we don't necessarily know are gibberish, but actually are in retrospect. And it's important for us to really get this right, because there's significant stakes riding on the results of these evaluations. And I think we really need to do our homework in terms of what these things look like and what they're actually doing in order to make sure that we can produce results that are actually informative, because these things matter. And we really have an obligation to try and get things right. So thank you all very much for your attention, and I'll be happy to answer questions.
Thank you, Chris. It looks like we have a question already. Ira, would you like to unmute and ask?
Sure. Thank you, Chris. That was fantastic and really interesting. I appreciate your talk. 2 questions for you. The first is your set of 10 kind of controls. How early or late were there? So, you know, we know the impact takes time to accrue. Were these projects that were funded 20 years ago or more recent, 5 years? And then the other question that I have is, do you think that we've defined the parameters for impact well enough to ask it to look? Do we know what impact is? And is it one of those things that we sort of know it when we see it, or do we have a clear set of parameters to look for?
Yeah, great questions. So first, most of these projects had been funded for at least 10 or 15 years prior to us sort of looking at it. So like we wanted to choose projects that were around and sort of had impacts like 4 or 5 years ago that we could then use. So in most cases, like I think the most recent set of publications was like 2015 or like 2020 or something like that. So they were a good 4 or 5 years old. And all of them had been sort of working their way through. So we sort of gave them enough time to sort of show what those things looked like. So yeah. Then to your question about do we know? I don't know that we do, to be very honest. I don't know that we know what impact looks like. I don't, to be very honest. I mean, you know, to be facetious, like in one way we do, in one way we don't, right? Like in biomedicine in particular, we sort of know exactly what impact looks like, right? It looks like people getting better. It looks like people having better health outcomes, right? But how do we get there, right? That's, I don't think we've sort of have a conceptual framework for like, what are all of the pathways to making people better to really sort of frame the question correctly. So I don't know that we're really there yet. I think that's kind of where we're still sort of in the sort of exploratory phase. So, I mean, you know, there are a lot of us who are sort of thinking about that and looking at different approaches, but yeah, I don't know that we actually have a full definition of what that actually is. So, Jeff.
Hey, Chris, thanks a lot. I agree, great talk. It was really both entertaining and informative, so I appreciate that. One thing I was curious about that initial framework for impact that you mentioned Elsevier had constructed that was being used for this. You know, I have to say one thing in its favor is that they have a framework, so that's very good. I'm curious, is there like any kind of formal write-up or documentation about that framework and how it was derived?
Not that I am aware of. But I know that Elsevier is very interested in using it. So presumably that once they start using it, they'll create something like that. But that is certainly something that I can go back to my colleagues there to ask them to do. Anecdotally, I've heard that a lot of it was sort of them looking through a lot of just sort of write-ups from either the ref or, you know, case studies from NSF, case studies from the NIH, and just sort of reading through a lot of those things and sort of extracting themes from that sort of qualitative understanding. That's kind of my understanding of how it happened, but I don't have anything formal that I can actually point to and say, go read this.
Okay, yeah, I kind of figured that was the case, but thanks a lot.
Yeah, sure. Any other questions? Robin.
Hi, I just want to say the same thing that others have said. This was very provocative and interesting. And, I've been listening to some talks inside and outside of NIH on AI lately. And I think some of the problems that you highlight are certainly on the minds of researchers who are trying to improve AI. So I do think they're being addressed. And, AI is in our life. Every time you go on Amazon, it's telling you what to buy based on what you've done before. So I think it's in the woven into the thread of our daily existence far more than we realize. But my question really was about the substrate for your AI, publications. As all of us here with the RTD TIG, we generally consider that outputs in the logic model so far away from impact. So my question is if, and I agree with you that people preventing disease or curing disease is sort of the societal long-term impact that we all look towards. And the problem with research being so distal from that downstream impact, you always have the problem of attribution. Was it the research? Was it the knowledge generated that created improved health? Or was it something else or, some type of combination? My question is, how were you able to really assess impact from publications since they are so distal from impact, unless the publications are a summary of the improved health that was had because the project's been running 20 years and the authors are able to make that attribution with that time frame. I have a fundamental question about that because I'm not sure that you can. I think publications can maybe identify potential future impact, but actual impact, I'm not so sure. So that's my question.
Yeah. So 2 points there. One is on the point of sort of using publications. I think you're absolutely right that like what we need to do is get it beyond just the publications, right? So in the initial run, again, we were using a public version of ChatGPT that was potentially trained on the web. So theoretically, maybe it might have picked something up from the web. But again, we didn't really get it to look beyond just the papers that we fed it. And again, I think your point is well made that like, if we train a model on publications, it's not going to know anything that happens outside of publications unless the publications actually tell us, hey, this thing happened outside, right? So yeah, I think to really do this, we need to train it not just on the publications, but like a huge slew of other kinds of documents that would actually have the kinds of impacts that we would be interested in, right? So we'd actually have to train it on policy documents and like legal frameworks and economic stuff and like just a whole range of things beyond just publications to really have it understand that impact and be able to tell that story correctly. So I think you're absolutely right about that. The other thing that I wanted to point out is one thing that I didn't mention in the talk is something that you brought up is that yes, people who are generating these things are kind of thinking about some of these aspects and trying to build better models, but not all of them, right? The people who are building models aren't thinking about all of the things that we are. They're not building in all of the guardrails and all of the things that we're interested in order to improve the model output. So I think it's really on us to push back to the developers of these models to the degree that we can to say, hey, look, you need to work on X, Y, and Z because these are things that we care about and these are things that we need to see in the model moving forward. They're not going to do it unless we engage. So I think it's on us to really push back against that to the degree that we can and really push for a bit more accountability and a bit more sort of control around developing the model in certain ways to be able to overcome some of these challenges. So I also wanted to put that out there as well.
Thanks. And I mean, you used ChatGPT, right? Not Chat, but
so
not
we did, yes.
GPT-4, which I mean, every generation of these models, people report is significant improvement. So I know I totally appreciate and think we have to be vigilant on all of this, but I'm just astonished at the rate of change of,
Yeah.
of this technology. And 5 years from now, we may be having a very different conversation.
I think
I
we
just
totally
ask
will.
people to think about what your life was like before the smartphone was introduced and how now it is like your companion. It does
Yeah.
everything, right?
Yep,
So thank you. Great talk.
sure. Thank you.
Okay,
Any?
well, thank you,
Oh.
everyone. We are at time. Thank you, Chris, for a great thought-provoking talk. And I've put some information into the chat for our upcoming webinar, but let's give Chris the last, virtual round of applause. And thank you, everybody, for your time.